Mhm. Convert 2:1 multiplexer into an OR gate.
Okay. 2:1 into 1.
Hmm.
Yes, sir. So whenever
Hmm.
A is
Hmm.
0,
Hmm.
B will be forwarded as it is. Whenever A is 1, 1 will be forwarded to output.
Okay. Okay. Can you draw asynchronous counter? Maybe 3 bits only. Up counter.
Asynchronous counter.
Hmm.
Okay. I'm just putting this excitation table, sir.
No problem.
K-map, can I put it in paper here itself, sir, or you want
You
it
can
there?
draw on your actually I asked you asynchronous counters. Asynchronous. In the diagram you are
Okay.
using synchronous. Okay. This is not correct.
Oh, okay.
Hmm. Hmm.
Okay. So will the output of first flop will be given as clock to the second flip flop, sir? This one is
What is asynchronous circuits? What are asynchronous
uh,
circuits?
asynchronous is clock won't be in synchronize to them,
To them meaning.
to each clocks in a counter.
Okay. Very good. Hmm.
Hmm.
They may work at different clocks, right?
Ah,
Hmm.
each one will be of with different frequency.
Correct. Then you
Hmm.
can give output of first other clock to the other.
Ah, that's what I was thinking. That
Hmm.
output will be going to the clock port only, but I was just confused between the data path and the
In the bottom you
clock
can
path.
redraw. In the bottom you can redraw. Okay.
Yes, sir.
Okay. Can you explain its functionality? Why you connected output to the clock?
Hmm. Okay. So what will happen is whenever this counter is changing its
Which is
value,
MSB and which is LSB?
this will be LSB
Hmm. You are right.
and this will be the
Hmm.
MSB.
Hmm. Okay. Can you explain now?
So here at every passage of clock,
Hmm.
uh, this will be maybe T flip flop. This will be a T flip flop, toggle flip flop.
Hmm.
So that initially it will have value 0. It will be propagated to 1, and this we are
And what
giving
is
as a
its input?
clock.
D? Input is D?
Sorry, sir.
Its input is D. What is this?
Uh, okay. Input to this toggle flip flop.
Hmm.
Uh, it will be like what to say. T and toggle flip flop is nothing but actually D won't be possible here.
Hmm.
What I'm doing is toggle flip flop is it will toggle its value for every clock cycle.
But then what is the purpose of input? If it is going to
Uh,
toggle its output on every
hmm,
positive edge of
hmm,
the
hmm,
clock, then what is the purpose of input? Right?
Input might be some enable or something to start the
No.
uh, counter.
Okay. Okay. Just for 1 minute, I am deviating. Now write the truth table of T flip flop.
T flip flop. Okay.
What is Q bar?
Next state, like one, it is the current output state,
Can you draw in the
and
middle?
when T.
Can you draw in the middle? Actually, it's totally going in the bottom.
Uh,
Now I have done zoom out. Yeah,
uh,
it's fine.
okay.
What is Q bar,
Yes,
Vikas?
sir. Q bar is the what will be the value when T flip flop gets this input, and if the output is of this value,
Hmm.
what will be the next output?
Oh, but then you
Not
are.
Q bar, I think Q next or Q dash, something like that.
Mhm. You should write QN actually. That
Okay.
previous one QN, next one you can write QN plus one.
Okay. Okay. Fine.
Hmm.
So input whenever depending on the value of the input, if it is zero, there won't be any toggle. But if there is one, then it will toggle.
Hmm. Correct.
Hmm. So since
Then
in
what
a,
you will
a
connect to
counter,
T?
sorry,
Then what will you connect to T?
uh, I should connect one.
Okay, then light one, है ना?
Hmm.
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 Okay.
Hmm.
Now explain.
So when one is always connected. So for every clock edge,
Hmm.
this will be changed. Initially, if it has value zero,
Hmm.
it will be toggling to one,
Hmm.
and part one will be propagated as clock here,
Hmm.
and here also we will have one,
Hmm.
one, and three flip flop.
Hmm.
So that here, when this clock edge is seen here,
Hmm.
then this bit will also change from zero to one here, so that we will get value.
Hmm.
And at the time here also it can toggle.
Hmm.
So like that it will uh, be propagating, and each bits will be toggled based on the values being propagated from the
Nay, if
uh,
see,
system.
see, as soon as positive edge of the clock comes on the first flip flop, that is LSB flip flop, your output will
Hmm.
go high, right? Previously it was zero.
Huh. Huh.
At the same time, your second flip flop is
Hmm.
also getting positive edge of the clock, right? Because it went from 0 to 1.
Huh.
And second flip flop
Yes.
output will also become 1 immediately. And similarly,
Second.
third flip flop will
Hmm.
also get the edge, positive edge. And that output will also go high, right? So that
Hmm.
means you are going from 0 0 0 to 1 1 1. Am I right or no?
Okay, we are giving 0 to 1 here. That is coming as a positive edge
That will become
here.
positive edge,
And
right? You understand? For the second flip flop.
huh.
Previously the output
Yes,
was
yes.
0,
When
now it is
this
1.
one, uh,
That become
so
positive edge for
that
the second
time,
one.
But here when positive edge is there, in next cycle only the value will be 1, no, sir. Here, this third
No,
flip
no, no,
flop.
no. Why next clock cycle? When you give positive edge to any flip flop,
Uh,
that
mm,
that passes its input effect, right?
that it passes the input in the same cycle, the value will be passed to the
Uh,
output.
at the
But
same positive edge. At
but
the same
effective.
positive edge.
Uh,
Hmm.
yes. So this value is being passed in the same positive edge,
Hmm.
but to this flop,
Again,
it
there is a
will be
part.
seeing that.
No, no, no.
Uh,
It see only
uh,
its own input. It does not care for other flip flops. Previously, you were applying 0 and now you are applying 1.
mm.
Hmm? Understand?
No, sir, I did. You are saying this for the second flip flop and third flip flop,
Uh-huh.
this clock will be coming in the same cycle.
Same cycle meaning what? When you say
This
same cycle,
positive edge will be seen at the same time, and both will become 1 1. You are saying?
correct.
No, sir. I thought only this. We will get 0 1 0 only next time, and then only 0 1 1. Because there will be delay in this flop for
Let us
when the
say your
positive edge is.
clock is 10
Uh,
megahertz. Okay, let us say 100 megahertz
uh, uh,
which is applied to LSB flip flop,
mm,
and your period becomes 10 nanosecond, correct?
mm,
And just assume that propagation delay of each flip flop
mm.
is 20 picosecond.
Okay. I got the point, sir. Since clock frequency is 20 megahertz and propagation delays are very less,
Hmm.
immediately only
Hmm.
these inputs both will be changed.
Correct.
That one I understood
And your
now
output
with
will become
respect to
1
clock
1 1.
frequency.
From 0 0 0, it will become 1 1 1.
1
Okay.
1 1. Yeah, yeah.
But we need 0 0 1.
Yes. Mm.
Okay. Try put NOT gate at the output of first flip flop and then apply it to the clock.
Not get
Uh,
output of the
uh,
first
uh,
flip flop.
uh, uh. Then try what is happening.
Okay. Immediately we are getting 0 0 1, and whenever 1
No, no,
is
no, no.
there,
When 0 was there, 1 was going to the second flip flop, right?
initially only it was going, correct?
Uh-huh. So when your first flip flop goes from 0 to 1,
Mm.
because of NOT gate, it will become 0 at the clock of
Correct.
second flip flop,
Mm.
right? That is negative
Huh,
edge of the
huh.
clock. So second flip flop will not take any action.
Mm.
Understood?
Mm.
And so
But it will also
obviously,
have value 1.
no,
Yeah.
initially it is 0,
But it
right?
will have.
No, no, initially it is 0, right? Initially all flip flops are at
Huh,
0,
huh. 0, correct.
right? Zeros.
Uh,
Huh.
but
This is our
now,
first state.
the-
And
uh,
input clock
mm,
of second flip flop was 1
mm,
because of this 0.
mm,
Now
correct.
when positive edge comes, your output of first flip flop will become
Mm,
1.
okay. Mm,
But NOT gate will give
mm,
output its output as 0.
okay.
No, no, no. This is
Mm,
1, right? This is 1. Input is 1 now. But output of NOT gate is
mm,
0.
mm, mm. Correct, sir. Here Q is 1.
Huh.
Here this input to this clock is 0. Yeah.
Huh. So that means
Mm,
negative edge, right? Right? Negative edge of the
correct,
clock. So
correct.
this,
Mm,
if you are assuming this flop is working
mm,
at positive edge of the clock, it will not take any action,
mm,
right?
mm,
So third flip flop will also
correct.
not take any action because there is no change in the output of the second flip flop.
Mm,
So you got your expected value 0 0 1, right?
correct. Yes, sir.
At least
Mm,
second thing you got.
mm,
Now try
mm.
next. What will happen at the next clock cycle?
In the next clock cycle, again we will be any one is there, so it will toggle. It will give the output 0.
Hmm.
So here since it is 0,
Hmm.
now it will here transition from 0 to
That is positive edge of the clock,
1.
है ना? Positive edge of the clock.
Passage will be detected here,
Hmm.
and
And
here since
output. But basically, by putting not glitch, you will
yes,
get
yes,
your desired result. Okay.
yeah, yeah,
Yeah, you
yes,
can
yes.
share your whiteboard by the way for other questions. Now, can you tell me what is the limitation of this
Okay, okay, sir.
asynchronous
Fine.
counter?
I think it is prone to glitches or something,
Why?
sir, because we are using
Hmm.
the data path in the control in the clock path,
Hmm.
so that it
Where
can
is the
have
glitch? Where is the glitch?
timing violations.
Where is the glitch? What? Where do you think is a glitch?
In the second and in the subsequent flip flops,
Why there is a glitch?
in the second or third flip flops.
Why there is a glitch?
Mm, not glitch. I was thinking maybe some timing violation since because they are in. We have this thing clock tree synthesis or
Hmm.
some concept
Hmm.
where the
Hmm.
clock pin should be used only to the clock thing and data path should be different. So if we use like this, then I think in that
No, no, no. I agree.
concepts,
I agree. There is a
I think
clock.
clock
Oh, no,
glitch
no, no,
can.
no. There was 1 minute. You are saying there is a clock tree. Okay.
Uh, uh, uh,
Agree. What is clock tree?
uh, mm. Clock trees from the source of the point, each flip flop is going right
Hmm.
to all the flip flops. That is
Hmm.
called the clock tree, sir.
Okay. If the input clock
From
is
one,
going to all the
maybe from PLL, there is a clock generator.
I agree. But
Uh,
if your tool is allowing us to connect output of any of the
mm,
flip flop to the input clock of the second flip flop,
mm,
then why do you think you are breaking a law? Because for other flip
okay.
flops,
Mm,
right, the same clock is going.
mm, mm, mm.
Only to these two flops you are making asynchronous. I want to use
Mm.
asynchronous counter. What is the problem?
Okay. Not able to think, sir, of
Okay,
any other answer. Yeah.
okay. Actually, you see now, when you give clock edge to the first flop,
Mm,
okay, try
mm,
to understand.
mm,
Output of first flop, it's okay. It is synchronous only to the rest of the design. If your design is synchronous design.
mm,
Now, when the positive edge comes on the
mm,
second flip flop, then only
mm,
that means there is a delay of first flip flop, then there is a delay of second flip flop to get the value on the output of second flip flop. For the third flip
mm,
flop, it
mm.
takes three flip flops, right? So now if my counter is 10 bits
Mm,
long or 16 bits long or
mm,
it's a
mm.
width dependent, right?
Correct, correct.
When
Mm.
what is my expectation, right? When I say counter means
In each clock cycle, it should change.
my value should change, right? And especially whenever you are making a
Correct,
counter,
correct,
right?
correct.
Ultimately, you are using that value at some other point of the design, right? That counter you are
Mm,
using somewhere else.
correct.
Now it is totally
Mm,
becoming uh, number of flops dependent. Your frequency is dependent on the number of flops.
mm.
Okay, before giving you the answer,
Correct,
okay,
correct.
before giving you the
Mm,
answer,
mm,
can you tell me
mm,
if I have one flip flop to another
mm,
flip flop synchronous path, okay? How will you calculate the maximum frequency of operation?
mm. We'll be calculating the TCQ of the first flip flop
Huh?
and combinational delay plus
Hmm.
setup time.
plus setup time of what?
I was saying setup time of the second flip flop, that is the capture
Very
flip
good,
flop.
very good. Okay. Now, if my design is asynchronous, like I asked you in asynchronous design, on what factors your
Hmm.
clock will depend? What will be your maximum clock frequency?
Okay. It it will depend on
Hmm.
uh, the last most flip flop. It is not just
No. Give me
launch
formula.
and capture.
Give me formula.
Huh? Yes.
In your counter, tell me the
For
maximum frequency of operation.
okay. In my counter, TCQ of less flip flop
Hmm.
and synchronization. Hmm. Here the clock is coming here. And TCQ of second flip flop
Okay.
as well as setup time of second flip flop.
Why? Why you are considering setup time of second flip flop? What is setup time of flip flop? Okay.
Setup time is the time required for the data to be stable
Hmm.
before arrival of the clock edge.
Hmm. And your input is one, right? Continuously tied to one. So then why do you think there can be setup violation? You are
Mm.
giving a constant value. Then you need not to worry about setup and hold violations. At least for those flops.
Correct.
Okay.
Yes.
Now tell
Mm.
me what will be your maximum frequency of operation.
Maximum frequency of operation will be the TCQ of all the three flip flops, sir.
Okay, very good. Why?
Mm. Because the clock for each clock,
Hmm.
the for the second and third,
Hmm.
the clock is dependent on the output
Hmm.
of the previous flop.
Hmm.
So for that, we have to know the propagation delay of each flops
Hmm.
such that the data will be stable at the output.
Huh.
So we are considering TCQ for all the three flip flops.
And what about not gates?
Yeah, sir. We have to add the combination delay for the and not gates.
Okay. So after that time, your output will be stable, you are saying.
Yes.
Okay, now this output is applied to another flip flops. Okay.
Mm,
Those flip flops are
mm.
synchronous with LSB flip flop. Can you tell me what
Okay.
will be the maximum frequency of operation for your design?
That will be the TCQ of all these three flip flops, this
Okay.
NOT gates,
Huh.
and then set time of this synchronous flip flop.
Hmm. You understood why, right?
Yes, sir.
Okay. Okay.
Mm,
Very good.
mm,
Now, as you said, right, you have T flip flops.
mm,
Usually in our FPGAs, we have only D flip flops.
mm.
I want to implement my counter with D flip flop. What should I do? I don't have D flip
Ah,
flops available in FPGAs.
mm,
What should I do?
mm. I think D flip flop can be converted into T flip flop.
Can you do that?
I just think so. These are, these are all coming like B-Tech things actually.
But this is basic thing I want to
Uh,
check. In your interview also it will happen like this only because firstly they will ask
okay.
simple questions. If you are able to
Uh,
answer them, they think okay this now let us go to the higher level. They will go.
uh,
Because the
okay.
basic thing will remain
Even
same.
for okay. Mm.
Now in your BTEC, did anyone ask you what will the maximum frequency of asynchronous counter?
Maximum frequency of asynchronous counter? No, sir. No. This is the first time actually I'm thinking. Yeah. Even in
Right?
my previous interviews also they didn't ask. Yeah. Hmm.
interview does not mean that you know something. We are trying to judge how you are thinking. Okay, now let
Hmm.
us let
Hmm.
us let us see how you convert.
Ah. Uh, so excitation table of the so just put excitation of
Okay, that at least you can know.
ah
Can you? Okay,
ah
I have a. Now let us move to next question. Or you want to attempt that
hmm.
also, or you can
It's
do it
fine, sir. I
later.
can just check
You
it.
can.
I
Okay.
can do it later.
Huh.
Hmm.
Now let us
Hmm.
say I want to
Hmm.
design a simple logic
Hmm.
where
Hmm.
input is sort of sometime it toggles, right? I
Hmm.
want to detect positive edge
Hmm.
on the input.
Hmm.
Positive
Positive
edge
edge of
detector.
the toggling signal.
Yes.
Okay, sir. Yeah. This is my input coming to the flop, and this is output. So whenever the input changes like this here, our out this Q will be one cycle delayed version of it. Now this is the area which we have to uh, detect the pause edge. So for that we can use this B and not off this one and connect it to a AND gate. So that the final output Y will be just this pause edge detection. Basically, whatever the input is there, I'm registering it with one clock cycle delay,
Right.
and I'm
Correct.
using
Correct. Correct.
input.
Correct. 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 Okay. Correct. Do you know what is race condition in digital designs?
Yes, sir. I'm aware. In race condition is uh, the output will not be stable at all. It will keep on changing into zero,
Right. Can
one,
you give me one example
zero.
of any logic where race condition will be there?
Okay. Uh, race condition. Mm, that SR flip flop has that race condition
I don't
at
want to
one
consider
one
S,
when
sir. I only want to consider D flip flop.
in
If
D
you are
flip flop.
considering
Okay,
any flip flop, okay?
okay, okay. In D flip flop, race condition.
No,
Okay.
I'm not saying in D flip flop. I'm just asking race condition.
Oh, for any
Any
logic
design.
circuit. Hmm, actually, I read this. Race condition. You giving to D.
Okay, one more design.
Hmm. Hmm.
Um, if you have a input which is one clock
Hmm.
cycle pulse,
Hmm.
I want to design a logic which should be able to stretch it by 3 clock cycles.
Okay. Okay.
Can you do that?
So we can just yeah, we can just put three flip flops
Hmm.
and all the clocks synchronous to each other to each of flip flops.
Hmm.
And here will be the pulse,
Hmm.
the first flip flop. It is being delayed
Hmm.
and given to this flip flop,
Hmm.
and further this is being delayed here, and we can just OR all the outputs
Hmm.
so that for 3 cycles it will be stress level signal,
Hmm.
and then it will be disabled.
Okay. If my pulse is,
Hmm.
I mean, active low.
Your pulse is active low. Okay.
Hmm. Hmm. Right.
Okay. 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 My pulse is active low. Hmm. Yes. Keep it. So it should be there for 4 cycles. It should be
Hmm.
active low, right? Right, sir.
No, no, no. Input is one cycle. One cycle active low. That's
Input
it.
is one cycle. our expectation at the output is it should be for 4 cycles
Yeah.
at active low.
Mhm.
Okay. What we can do is we can keep
If you put AND gate instead of OR gate, will it work?
for this active low you are saying, sir.
Hmm.
Uh, yeah, but it will work, but it will be already all will be in zero only, no, sir. It's not exactly at here, right?
Hmm? Why?
1 minute. My pulse is zero. Okay. Mm, yes, sir. And gate will work.
AND gate will work, right? That
Mm,
was I was expecting.
okay.
Okay, if my input is 3 clock cycle pulse
Mm,
and I want to make it 1 cycle, what will be my logic?
3 cycle pulse. Okay. This same logic can be used, no, sir, for that. Delay that input signal by 1 flop and then using this.
Right. You are right. Good. Okay, now I want to design a logic. Okay,
Mm, mm,
its input can be anything.
mm,
1 cycle pulse, 2 cycle pulse, 10 cycle pulse.
mm,
But output should be only 3 clock
mm.
cycle.
Okay. Output should be only 3 clock cycle pulse.
Yes. Or four
Okay.
clock cycle, whatever you want to consider.
Mm, mm, mm. Okay. I think the same.
Hmm.
Okay.
Answer is very easy.
I was thinking to put AND gate here,
Hmm.
but still it won't work.
When I will tell you the answer, you will say, "Oh man, it is so easy."
Mhm. Just take.
Okay, let me tell you.
Huh.
If you give your input pulse, maybe 10 clock cycle or
Mm,
1 clock cycle to your positive edge detector, it will always convert it
mm.
into single pulse. Output will be
Correct.
single pulse, and that single pulse you
Huh.
can apply to your second logic.
Oh, these two logics you are combining. Okay.
Mhm. You can
Okay. Okay.
combine,
Okay.
right?
Yeah. Got it, sir. Got it. I was just thinking about whether in the second logic itself we do any optimization. I
Mhm.
didn't think of both.
Mhm.
Yeah.
Okay.
Mm.
Mm. Do you know what is the disadvantage and advantage of asynchronous reset? Do you know synchronous reset, asynchronous reset?
Yes, sir. Yeah.
What is the advantage of synchronous reset and asynchronous reset, and what are their disadvantages?
The synchronous reset is the reset will be applied with the clock edge. In
Hmm.
asynchronous reset, it can be independent of the clock.
Hmm.
So, uh, so in synchronous reset, the advantage is
Hmm.
since it's always aligned with the clock
Hmm.
during session and de-session, there won't be any metastability.
Very good.
But but in asynchronous reset, uh,
Hmm.
the thing is, since it can accession and deaccession can happen at any clock edge,
Hmm.
especially the deaccession of the reset
Hmm.
can lead to metastability. That is the disadvantage in asynchronous reset.
Hmm.
But the advantage is in asynchronous reset, we can reset the flops immediately without even clock, we can just reset the flops.
But why
But
we want to
here,
make it independent of clock?
uh, because there will be cases where our logics might have clock gating logic to
Very good.
reduce power
Very good. Very
something.
good. Yes.
Uh, so if clock gating techniques for saving powers is used,
Hmm.
then with synchronous we can't apply reset at all.
Then what is the remedy?
So in asynchronous reset, we should use a reset uh, synchronizer.
Very good. Reset synchronizer, right? What does reset synchronizer
Yes.
do?
Reset synchronizer, when we are deasserting the
Hmm.
reset, it will make sure that the deassertion happens with aligned to clock.
Very good. Okay. And what about assertion?
Assertion, it will happen independent of the clock.
Right. That is the functionality of reset synchronizer, right?
Yes,
Hmm.
yes.
Right. Okay. One last thing
Mm,
in this.
mm, mm,
I have an input.
mm,
Okay.
mm.
Maybe you can write down. One
Okay,
input name is, let us say, valid signal.
okay. Mm,
Another signal is data signal. You may have
okay.
heard, right? Valid data signal, right?
Yeah, yeah, validity protocol. Yeah,
Valid and data. I have valid and data
yeah.
only. Okay. I don't have any
Mm,
ready.
okay.
I have one signal valid. Data you can consider
Mm,
8-bit or 24-bit. It's not a problem. But
okay.
the problem is,
Ah,
once my valid goes high, it always remains high. It is not
ah.
like it is going zero and data is not valid. Okay.
Okay, always it is high. Okay.
Let me draw. Maybe let me take control. Let us say, are you able to see now?
Ah, yes, sir. I'm able to see. Mm.
Usually what we say, valid should go zero. है ना? When data goes zero. But my valid is, it
Yes.
goes zero and it remains zero. So it remains high and it remains high there. Once it goes high.
Mm, mm,
So let us say this is my first data, which is valid one. Okay.
mm,
Then this is second data.
mm.
This is my third data. Now we have only 10 minutes
Okay.
for this session also.
Okay, okay. Mm,
Here instead of this third data extends actually, okay, for many
mm,
clock cycles.
mm,
So we have to pick only once. Now here again data changes.
mm.
Okay.
Okay, okay.
For two clock cycles, let us say, na? And
Mm,
this data
mm,
I have to take for both the cycles because it is a valid data and so on.
mm, mm, mm.
Now from this valid you cannot identify, right?
Yes,
To
yes.
facilitate this, what I am giving,
Mm,
I am giving you address here. Let us
mm,
here I am giving you address one. Let us write here address.
mm, mm,
Here I am giving address two, right?
mm,
So from
mm,
this address you can identify.
mm,
Here I will give you for this reason address three. So you can
mm,
know that it is single. Here I will
mm,
give you address four, है ना? Here
mm,
I will
mm,
give you address five so that you can pick the same, even though same data, and so on.
mm, mm, mm.
How will you pick the valid data?
So I will be um registering the address whenever this valid comes,
Hmm.
and when my input address and the registered address, if they are different,
Hmm?
I will be giving ready to accept it.
Where is ready?
If
Ready is
there are,
nowhere. Ready is nowhere. I just want to, because now
uh,
data has random values also, which should be discarded. Out of this
okay.
data, I want to extract only valid data.
Mm, mm. Yes, sir. So what I'm saying is, let's say we are putting everything inside a FIFO, maybe.
Hmm.
Okay. For the FIFO write enable, the
Hmm.
condition will be this valid
Hmm.
and input address
Hmm.
not equal to the registered address.
Very good. Uh, can you draw what
If
is
that is,
that logic, particular logic?
so I'll be having this will be a multi-bit flop where I'll be registering this address
Hmm.
of how many bits it is.
No problem.
So this will be our address or something,
Hmm.
registered address, and I will be having a valid signal also. Mm, this is clock,
Hmm.
and for this clock, I will keep an enable signal as this valid. So whenever valid is there,
Very
we
good.
will be registering this flip flop or this
Now,
address.
what is this signal you apply to flop?
This valid signal as enable.
What is? Do you have enable signal to any flip flop?
We don't have, but
Then
what to
why are you
say?
taking?
Okay, I'll just put it in
Hmm.
this way, maybe, or I'll put a mux
Hmm.
here. So if this mux, if it has valid, will be the select line for this mux.
Hmm.
If the valid is 1,
Hmm.
input address will go to this address.
Hmm.
Otherwise, this registered version will be returned to this flip flop
Okay.
based on this
What
valid.
is the second input?
So the second input is this out registered version of address.
No. That you have kept
Hmm.
open, na? What is the input?
This is actually address.
Oh, this is address. Okay. Uh-huh.
This is a mux saying whether the input address I should take or this registered address I should take.
Hmm.
And for that validating signal, I'm using as a mux here.
Hmm.
So that whenever it is 1, this address we are always using it in this registered address.
Hmm.
Okay. And FIFO write enable. Let's say we are storing it in some FIFO.
Hmm.
For that, the write enable will be
Hmm.
valid
Hmm.
and a comparator will be used. Address, input address not equal to registered address.
Hmm.
Only if this condition is there,
Hmm.
we will be taking this data and we'll be putting into this FIFO. If you see at this point, since we have already registered the R
But that
address
is why
as
I'm
3
saying
and
this
here
logic is not required, whatever you have done.
this mux you are telling, right?
Marks and this flop. Why? Register is required, right? Because you are
Uh, uh.
taking not
This
of that.
is required. This is
This
required.
is required. This
Hmm.
marks and all is not required. Yeah, this will work.
So,
This will work.
so that is the thing. Again, when it changes to 4, it will take this data.
So 5 output will be only validators, right?
Yes, yes,
Because
yes,
you are not writing the. Okay,
yes, yes.
Vikas, I think it was good. Anything you want to know? Otherwise, at least for today, we will close it. In the next meetings and
Okay,
all, we will focus on. At least now, I could grasp your level also. Okay. So in the next meetings, we
okay,
will
okay.
think of study timing analysis, CDC,
Mm, mm,
right? Those type of stuff also.
mm.
And then
Okay,
then
okay.
we'll go in the depth also.